Hi everybody, my name's John Exton. I'm a STEAM teacher and I've been a primary school teacher for 33 years. And I know you guys are looking at maths manipulatives, and I've got this one called a numerule that I want to show you because it really helps with maths problems. And this is quite a famous one here called the locker problem. You might have heard of it. And we are going to solve that using this little device here. Okay, so but the thing about this is it can, you can explore all sorts of number patterns and multiples and factors and addition, subtraction, multiplication, division, and lots of other concepts with it. So it's quite good. Anyway, let's have a look at this. So using the numeral, solve the locker problem. Now, generally, people ask this problem in relation to using the number 100, okay? So generally, the problem goes like this. There's 100 students that are assigned to lockers, 1 through 100. The student assigned to locker number 1 goes and opens all the lockers. The student assigned to locker number 2 then either opens or closes multiples of 2. Then the student assigned to locker number 3 opens or closes multiples of 3, okay? And then student number 4 opens or closes multiples of 4, and so on for all 100 lockers. So I suppose what we want to find out, how many lockers are actually opened at the end between 1 and 100. Okay, now we're not going to do 1 to 100 because it could take some time. It'll be fun. You can do that in other ways, but you can certainly explore this thing and you will understand the pattern as soon as we get there. And we're going to use 21 instead, and you'll understand what I'm talking about. So instead of 100, we're going to only explore this pattern up to 21. See how many lockers are open at the end of 21. I've just written this down here. While this problem uses 100 lockers, you can actually pick any number and you'll understand the pattern that arises. Anyway, let's have a look at what happens here. So first of all, student number 1 comes along and opens all the lockers. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21. You could go further if you want to, but I'm just taking that as 21. Good. Student number 2 comes along and either opens or closes lockers, which are a multiple of 2. So 2, open, 4, 6, 8, 10, 12, 14, 16, 18, and 20. So that student was always only going to open lockers. Okay, close lockers. All right, so let's have a look at multiples of 3. Third student comes along and only multiples of 3 either opens or closes the lockers depending on whether they're open or closed. So 3, 6 goes down. 9, 6, 9, 12, 15, 18, 21. All right, so we've got quite a few doors that are opened or closed here. Student number 4 comes along and then opens or closes lockers depending on whether they're a multiple of 4. So 4, 8, 12, 16, 20, and nothing after that because we're not going past 21. Student number 5 comes along and opens or closes lockers which are multiples of 5. 5, 10, 15, and this time 20 comes up. Student number 6 comes along and does multiples of 6. 6, 12, 18. Cool. And nothing after that. Student number 7 comes along, does multiples of 7. So 7, 14, 21. Nothing after that. Student number 8 comes along, does multiples of 8. 8, 16. Nothing after that because the next would be 24. Student number 9 comes along. 9. 18. Student number 10 comes along. Does multiples of 10. 10. 20. Nothing after that. Student number 11 comes along. 11. Can't do 22 because we're only thinking about 21. Student number 12 comes along. 12. Nothing else too big. Student number 13 comes along. 13. Student number 14 comes along. Student number 15 comes along. Student number 16 comes along. Press it down. Student number 17 comes along. Student number 18 comes along. Student number 19 comes along. Student number 20 comes along. And student number 21 comes along. And we've finished our sequence. Now, can anybody see what the pattern is? 1, 4, 9, and 16. Now, this will continue all the way up to 100 and beyond. So, I'm sure you can see the square numbers. So, we could probably work that out. There's 10 square numbers between 1 and 100. So, the answer to this one would be 10. All right? And what an amazing thing. So, that is a great sort of manipulative device that you can use for number pattern. That's the numeral. Anyway, the locker problem. Yeah, check that out with your kids. It's fantastic. You can probably use other materials if you want to, but that seems to be pretty good. Thank you. Bye.